Hey guys, it's Sam for Digital Meat, and in this tutorial I'm going to be looking at the Realflow plugin for Cinema 4D. That's what won the vote on the website, so that's what I'm doing. So this will be the first in a series of tutorials I'm going to do on Realflow, the Realflow plugin. I'm going to start off with the basics and the emitters, so that way I can go through everything within the plugin over the course of a few tutorials. So let's just jump straight in, I suppose. Okay, so first off, once you've installed the Realflow plugin, you'll get this menu up here. So if you go to the top to Realflow, drop down, you'll get this menu. Now, everything that you're going to do with Realflow is held in what they call a scene tree. It's quite similar to, I think, X Particles has something like this as well. So I'm just going to go to the top and create scene. And within this scene, you get meshes, emitters, fluids, daemons. And these are kind of nulls for each of these kind of objects. So they're kind of like holders, really. But this scene tree gets created by default when you create a Realflow element. So if I delete the scene tree, and seeing as we're going to be dealing with emitters, I will go down to emitters and create the top one on the list, which is a circle emitter. And you can see that it creates the scene tree for us, and it's created this emitter object and this fluid object. Okay, let's start with the emitter. The emitter is basically the emitter is basically where particles get generated from in 3D space. So you can move it around. As you can see, you've got this, which is the direction of flow, this arrow. And also you have these markers which signify radius. Not radius. Let's go to the object. So that'll be width and depth. So you can see that you can size those two things there. So I'm just going to go straight back to normal. So this is the thing that determines where the particles are generated from, and this fluid object, which got dumped under the fluid null, this is the thing that contains those particles. So let's start with the emitter. Let's bring this up a little bit and just hit play. As you can see, as soon as you hit play, it starts generating particles. Now, I'm just going to pause this a second because that might be hard for you guys to see. What I'm going to do is I'm going to click on this fluid object, and if I go to this last tab, display, you can actually make the size of the particles bigger. So I'm just going to give it, take it up to 4, so it should be more visible for you guys watching the video. There we go. That's a little bit better now. You'll notice the colour of the particles are blue. And if you go to the display on the fluid, you'll see this gradient here, which signifies particle colour. Now this is based on velocity. So the faster the particles are going, the lighter they become. And obviously you can see in the scene that they're at constant speed at the moment. Okay, so let's go through the emitter types. Oh, one more thing before I move on. If we click on the scene and then go to the solver, I just want to go through this briefly. So this global tab here, it says number of threads and it says 12, which is correct for my chip. I've got an i7 and it's a hex core. So multi-threaded, that's 12 logical processors. So that's correct. Usually this will figure it out for you, so you don't have to worry about anything about that. These are just the sub-steps with the solver. There's several different types of solver, and then at the bottom, this is what I'm going to talk about, the GPU. So you can say use OpenCL GPU or use CUDA GPU. Now I've got an NVIDIA 970 and it should list it here. I've actually got 2 in there. Unfortunately, I can't use both. Realflow only uses 1 GPU at a time. So I have got a CUDA GPU, so I'm going to tick that on and choose this. You'll note that if you actually click this help button, and in fact I'll do that now, and have a look at this and go down to the bottom for GPU, it will say this option is only available if your graphics card supports OpenCL GPU. I think that's a typo. It should say CUDA GPU. With very fast multi-core CPUs, the GPU's impact on the simulation is often negligible. Now my CPU's getting on a bit now, and my GPU's a lot newer, so it actually should help. In your case, it might not always bring anything to the table. So I'm just warning you. Okay, so now that's dealt with. I mean, playback's pretty much the same, maybe a little bit quicker frame rate. So let's have a look at the emitter type then. So if we click on our emitter object, we've got a basic tab like you normally would with any Cinema 4D object. Coordinates, so this is where it is in 3D space, its scale and its rotation, all of which can be animated like any other Cinema 4D object. Sorry, just taking a drink. And then we've got the emission. So this is the important one. Okay, so let's just play our sim. Let's crank this up to 5 seconds, which you can't do when a Realflow simulation is playing for some reason. Okay. So the emitter type, it's currently set to circle. I wonder if that... okay. Let's just go through this. So that's set to circle, okay? The volume, it creates a defined volume of particles. The size of the volume is defined by the emission area and the value entered in this space. So the emission area would be the size of the emitter, and I think this volume is... So, okay, as you crank up, you can see that the volume is being created. So let's just say 153. Go back to the beginning. So that's what it does. It creates a volume of particles, and that is it. Okay. So let's crank that down. And then we've got the speed. So this is the speed that the emitter cranks out particles. So if I crank this up, you can see that they start coming out faster, and you can even see that they're... So obviously if it's at a faster speed from the beginning, you'll notice they've got lighter as well because its velocity's increased. And if you remember what I was saying about the display tab on the fluid, in the viewport it displays increased velocity lighter. So let's go back to our emitter. So the great thing about this speed thing is you can actually change... Fuck's sake. You can actually change this value and animate that value. So if you wanted to, you can have particles coming out at this speed, and then halfway through it cranks up, and you can see that the particles interacted with each other there. So if I crank it back down again and then crank it up, you can actually see that there's actually some play. So if which is really, really good. It's what you'd expect from a fluid, so that's good. Okay, so that's just basically the speed that it comes at the emitter. Then we've got vertical random. So if you don't want it to look regular, if you don't want the emission to look regular, it's possible to randomly displace the particles. So if I turn the vertical random down, you can see that it's much more uniform. If we go into a side view maybe, yes, can you see this? Very, very uniform. But if I crank up the random vertical, you can see that now they're kind of mixed together a lot more, which is probably a lot more realistic, I suppose. By default, it's set at 0.5, so I'm going to leave it on 0.5. Okay, so the next thing we can have a look at is the horizontal random. So this is the same thing, but to avoid regular emission, but it's to displace the particles horizontally. So again, if I go into this, let's turn the vertical random down as well, because then it makes it more obvious. So very, very uniform. If I turn the horizontal random right up, you can see that it randomizes their position from side to side. So at 0.5. So both of these at 0.5 is probably a good value to get some kind of random emission. Although by default this horizontal randomness is set to 0.1. So that's probably good, especially if you don't want your fluid spreading out. Side emission, if you click that on, it just emits from the side of the emitter, like that. So you can, it's pretty obvious what that's doing. And then this ring ratio, you can see there, if we zoom into the emitter, you can see that it's just a solid thing, but this creates a ring. So it will emit from everywhere, but not that middle section. And obviously you can tweak this to control where the particles are coming from. It could be a very thin wall of particles if you wanted to. So that's just, you know, some options for the emitter there. So let's crank all this back to normal. Reset to default. I think that's all normal. Yep. Okay, so that's the circle emitter. Next, we've got the cylindrical emitter. So this is just an emitter with this shape, and it obviously craps out from the side. Much the same values as the other, the circle emitter. So we've got a vertical random, horizontal random, and a speed, so you can control how fast these are coming out. And that's it. That's all your options for that one. Next is the fill emitter. Now change to that and not a lot happens, so we're going to need some geometry for this one. So if I create a cube, and then we'll go back to our emitter, it says body. What's the body? So if we drag our cube into this field and then play, not a lot seems to be happening apart from now this, and it's because the cube is still visible. So if we hide our cube, we can actually see what's going on. So basically all it does is it fills the cube with a uniform amount of particles, or you can create particles on its surface. So where is it? Fill volume. I wonder what that does. Okay, so let's have a look. So so the body, you can drag any closed object into this slot. I think it does have to be closed. Then we've got this jitter value. So if I just let this run as it is with these settings, you can see that the particles kind of shift slightly. They kind of reorganize themselves a little bit, as you'd expect. So this jitter value, by default, the emitter creates a regular particle distribution. So obviously it leads to some patterns which you can see. So from the side, it's very regular. Do you know what? I really find it quite cool that in this view, because of the way the particles are laid out, look at this. Look at this. Because of the regular pattern of the particles, it gives rise to this kind of mathematical feature. It's cool, man. Very cool. But anyway, if you didn't want that, the jittering basically sorts that out. It adds random displacement to the particles. So let's just crank up the jitter into, there you go, already, look, very uniform, and then crank it up. It adds some noise to it. If you put it right up, it's completely random, and there's now no longer any recognizable patterns within this shape, which is great. And it also adds noise to the simulation as well. You'll notice that all these simulations at present, apart from the emitter ones, look like they're kind of taking place in space, and that's because our scene is basically an empty void. There's no forces. Well, there are forces between the particles, so they can interact with each other, they can collide and all that kind of stuff, but the scene globally at this point does not have any forces, so no gravity, there's no turbulence or wind noise or anything like that, and that's where these come in, demons. And that's how it is pronounced as well, demons. That's just an old archaic spelling. I think it's from, I don't know, the mid-16th century or something around that time period. But yeah, so demons are basically forces. So we'll come to those in another tutorial, but just letting you know. So if we go back to our emitter, so that's what the jittering does. The seed is, so let's bring the jitter right down and go back to 0. The seed is to change the initial distribution of particles. So if I crank this up, not a lot changes because it's very uniform. But if I turn the jitter up and then change the seed, you can see that there's some slight changes in the distribution of the particles. So that's all that's doing. So let's put this back down to 0 and 0. The fill ratio for X, Y and Z, they're all set to 1 at the moment. So 1 being 100% and 0 being nothing. It's to achieve partial filling. So you can choose how full a direction is. So if I crank X down, not a lot seems to be happening. Oh, that's better. It just needed to refresh. So, I think it's actually got to be. It's got to be playing. Okay, so this is the Z ratio. So you can see that particles are being created and destroyed. This is the height ratio, and this is the X ratio. So with a combination of those things, I could actually say, right, I want to choke this down to 45%. I want to choke this down to say 0.6, and this down. So you can kind of choose how full the object is. So I'm just going to return all of those to their default values of 1. Layers to remove. You can delete particle layers from the outside to the inside, and it creates a gap between the object and the fluid. So if I wanted to, as I step this up, you can see that it's cranking, it's slicing off layers from the outer edge of it. So that's all that does. Fill volume checkbox. With this activated, it will fill the object with particles. Yeah, I think that's all that does. It actually makes sure that the volume's filled. Layer, the next checkbox, as you can see, it's greyed out here. And for you to use this, you have to uncheck fill volume. So with fill volume disabled, the particles are spread over the object's surface. It doesn't create a particle stream when the emitter's associated object carries a texture. Okay, cool. So apparently this creates particles. So I need layer checked on. So yeah, this just creates particles over the surface. So as you can see, it's just a cube of particles. That's quite beautiful, really. They kind of cave in on themselves slightly, attracted. Okay, so yeah, that creates a layer of particles on the surface. Now underneath, you'll notice that we have this texture slot. So basically what this means is, and you'll notice that if we've got layer turned off, that this texture slot, I don't think it's available to us. So with layer turned on, obviously you get this thing on the layer, but you can also use this texture slot to define where on the surface these particles are actually generated. So let's test this. I'm going to make a material. Turn on the reflectance because we won't need it, and in the color channel I'm going to drop this down and create a gradient. Go into the gradient, and I'm going to choose a circular gradient, and I want it to be a lot more sort of harsh, so I'm going to drop that down and choose this to none. So now we get this kind of thing. So a black value is that where there's nothing, and a white value is a positive value, so that's kind of like 1, so 0, 1. So I'm going to copy this black knot and bring it up here. So in this white area, that will be particle generation. I'm going to do it again, like this, and do this. Nope, I'm not. I need the black one, and do this. So now we've got this kind of pattern. And I think... So particles are only created in areas with texture values, so colour greater than 0. Texture tags and projection methods are not evaluated. The emitter uses UVs only. So what that basically means is if I try and drag this material into the texture layer, nothing's going to happen. I have to open it up, and it's actually this texture that it wants. So if we go back to the emitter now and just grab this image and drag it in, you can see its gradient, and rewind this and play. Bugger all happens. And it's because this cube is still a primitive object, so it needs to be editable. It needs UVs for this to work. So if you press C, hopefully now something will, there you go, something will happen. So you can see that it's creating particles just where our white sections are in this texture. In fact, I think I'm going to make it a little bit more obvious by cranking up the amount of particles. Now, because this isn't actually emitting any particles, it's just creating it on the surface, what I'll need to do is go to the fluid and go to the fluid, and then we've got this resolution. So just to demonstrate, I'm going to change my emitter back to the circle emitter, go back to the start, and we can see all these particles are being shat out there. Let's go to fluid. So the resolution basically describes, in fact, let me tell you its definition from the help. With this setting, you can change the amount of particles. When resolution is set to 1, a volume of 100 centimeters by 100 centimeters and by 100, so 100 centimeters cubed is filled with 1,000 particles. So obviously, if I set the resolution to 2, it means that a 100 meter cubed area is going to be filled with 2,000 particles, if my understanding is correct. So the resolution's already 2, so let's make this 3. Let's make this 5. Now you can see the stream is a lot more dense, so it just means that the particles are closer together and there's more of them, which generally will give you a better fluid simulation, and it will demonstrate what I was talking about a minute ago for my emitter as well. So if we go back to the emitter and turn it back to the fill type, you can see that it's a lot more obvious now than it was before. So if we go back to the fluid again and say crank this up to 8 and then reset the thing or play it, there's a lot more particles. Not as many as I thought actually. Let's try 15, see if that, there we go. So yeah, there's more particles to describe that texture that we had there. And there we go, they'll all attract. So you can get some pretty interesting results from that emitter. Okay, we're done with that emitter. I don't think there's anything else there. So where was I? So the next one on the list I think is the image. Ooh. Let's go back to the beginning. So the image emitter. Now, because I had a gradient in the emitter before, it's dumped it in this texture slot. So this image emitter, it lets you load a single image or an entire image sequence into this as an emission mark. So if you took a video and converted it into an image sequence, you could actually have a video sequence in here playing, and the particles would be shat out in a using the values from that video. So the lighter the lighter the image, the more particles get emitted, and the darker So I think it probably works on a grayscale value. Excuse me. So, so we've got some of the same things as we did with the circle emitter. We've got the volume, so it'll just do a specified volume amount. We've got the speed, we've got the vertical random and horizontal random. The only difference is that we have this texture slot that the gradient's in at the moment. And if I play it and go above, you can see that the shape of my gradient is being upheld. In fact, let's make this object a little bit bigger. Let's make it around 200 by 200. So there, you can see my gradient is being respected, and that's where it's emitting from. So yeah, you can use any image in that though. Also, it's probably good to note that while the simulation's happening, I can move this, which is great. So it means that I can animate this object and the simulation will run, you know, as such. Also, all the other stuff, you can rotate this emitter. So, you know, you could whack this emitter on the end of, I don't know, an animated hose or something like that, and it would react accordingly, which is really good. It's great, really. So let's grab this emitter again. Oh, and scale as well. Scale works, so I could scale this in and out. So that works as well. Okay, so I think that pretty much covers the image emission type. Let's get back to our emitter object. So, image, linear emission. I think this one's rather boring. Okay, yeah, it is. This one's like it's a two-dimensional emitter, so it doesn't actually have any sort of thickness, if you like. It's just on the X and Y, and again, it makes a curtain like, you know. So this height, this is a lot like the volume type. It will just make a curtain of particles. So like if I say, okay, 190 centimeters squared, bang, that's what it will do. It will create that. So that's rather boring. And just like the other ones, you get the vertical random, horizontal random, and the speed. So it's a little bit like a waterfall, really, that one. So yeah, that's pretty much the long and short of it. Let's go to the object emission. Okay, as you can see that it's already populated the body bit here with the cube, but I'm going to delete this just to make it a bit more interesting. Okay, so as you press play, nothing happens because it needs an object. So let's try this with the sphere. So there's a sphere. Let's go back to the emitter and let's drag our sphere into body and hit play. There we go, look at that. I'm just going to go back to my fluid and turn the resolution back down from 15 to 2 because it was a little bit overkill. Okay, so there we go. Looks like a slow motion explosion or something. Okay, so let's have a look at the emitter then. So, like always, we've got the speed, so I can slow the speed right down, or I could speed it right up and that'll push those particles out, bang. Okay, so let's put that back to 200. We've got the randomness. Again, this is to avoid patterns and regular structures by displacing the particles randomly. So if we crank this up, well, you can see the velocity of the particles as well. So if I crank this right up, bang. Yeah, so we're getting some heavy interactions there. So let's turn this back down to 1 and then just slowly, incrementally crank this up and see what happens. There we go. So we've got, there's a lot more randomness there now. It looks way less uniform. Crank it up to 0.3, 0.4, 0.5. we should start to see a velocity change as the particles interact and bounce off of each other. So they should get lighter. Yeah, they're definitely lighter now. Let's try 1.5. Yeah, so a lot more random. Getting some good collisions there. That looks like a planetary explosion or something like that. I'm just going to turn this grid off so it's not in our way, so we get a nice view of this. It's quite mesmerizing, really. Okay, so I'm just going to leave the randomness on for the time being. Distance threshold. Here you can determine how far away the particles should be from the object's surface during birth. So if I turn the sphere... Oh, I don't think it's visible anyway, actually. Let's go back to that. Oh, there it is. So if we get right in there and have a look at this. So you can see that they're being generated from the object's surface, and if I turn this distance threshold up, you'll see that... Let's crank it right up. Yeah, you see they're being generated a lot farther, well shit, like very far away from the actual object now. And so they're 1,000 centimeters away. If I bring this back down, they should start getting generated. They should... Oh! That happens sometimes. I haven't ironed out all the bugs yet, so I will restart and then continue recording from then. Okay guys, so I'm back, and we've got our scene back again. Okay, so I'm going to just crank this randomness down to 0. I think we got to distance threshold. Yeah, next is jittering. So you can see this is very, very uniform. If I add some jitter to it, let's just say 2. Didn't do too much. Let's crank it up a lot. And yeah. Okay, so this is kind of like jitter in Photoshop for a brush. So if I go to the top view and crank this down, press play, you can see this. Very uniform. And even when I add randomness, I think it adds overall noise. Yeah, it does. Oh, shit, I forgot about that. So let's add this much noise. So yeah, it's just sort of random generation. So let's knock this down. So this is clean. Let's crank the jittering up to 0.5 and see what it looks like. So it's almost kind of like jittering in the emission direction. So instead of being really, really uniform, so let's have a look. So you can see that they're released at regular intervals, like clockwork. But if the jitter's up, it kind of randomizes that emission time. You know, forward, backwards, you know, you name it. If I crank it right up, yeah, but you can see from side to side it's still quite uniform. So if we rack the random up to 0.9, so a combination of these could result in something nice and random. If that's what you're looking for, you might be looking for something that you know, is uniform. So anyway, let's reset these back to their defaults. Parent velocity. The emission object can be animated, and Realflow for Cinema 4D takes a certain amount of the object's velocity and transfers it to the particles during the state of creation. So let's move this. If I grab this sphere and keyframe it at 0 and keyframe it back to that position. And then what I can do is say here, go here, and then at this point go here. So it sort of goes around in a little bit of a triangle. So it does this, and then play it. So that'll be animated. Like it should be. But you can see the emission particles are just emitting from it. They're not actually taking any of the force of the sort of object with it. So let's have a look at the emitter and put parent velocity up to 0.5. Ooh, up to 25. So now you can see that that's actually, you can see the colour has changed because the velocity of the particles have changed. So it's actually transferred some of the energy from the velocity of the emission object into the particles itself. Let's crank it right up. Oh yeah, love that. Love that. They're being shot off into space. Bang! So that's nice that you've got the option for that, because there's no point doing all that calculation if there's no need for it and you don't need it, or it doesn't, the simulation doesn't warrant it. But it's nice that it's there as an option. You can crank some of that in there. Yeah, really good. Really love that. Okay, so let's undo some of this animation and go back to the beginning. So the other thing, what else have we got? Smooth normals. This function should be used when the emission appears to be random or fuzzy. Okay. Smooth normals. Maybe it takes the normals of the object. Let's check it out. Emitter, smooth normals. I really didn't see a difference. Maybe. I don't think there's a lot of difference. Maybe it's one of those things where if it's not quite right, check that box and see if you get a result. Maybe that's the deal with that one. And again with the texture, emission type. What have we got? Faces, vertices. So yeah, you can see that they're coming out the vertices now. So if I go to display ground shading lines, you can see that the particles are actually coming from the vert points now. And if I change to faces, you can see that they're being generated from the inside of the polygons. And it looks as if there's 2 to 3 emission points for each polygon there. And I should imagine if you whacked up the resolution of the fluid, in fact, let's check that now. If I go to fluid, fluid, and crank up the resolution to 5, yeah, now you can see there's a lot more emission points per polygon now. But they are coming from the faces, so very good. If you can hear a whirring in the background, that's my computer, and it's my GPU kicking into action every time I play this. Okay, so that controls that. Then we've got this texture type. I'm going to have to make that material again quickly. Sorry about that, guys, because of the crash. Yeah, that'll do. Let's get that on this object. Now that's strange. Let's hide it. And then go to our emitter, and we've got to choose our texture type. Oh, this has got to be a editable object as well. And emitter, grab that, lob it in there. Let's actually see what this looks like. Okay, so we've got, okay. So it's kind of like an eye. So they should be shitting out in that direction. So look. Ooh. Another crash. Goody goody gumdrops. So it obviously didn't like that. Okay guys, I'm back again. I'm not sure why these crashes are happening. It may be they need to make improvements to the plugin. It may be that there may be some, it's locking heads with another plugin I've got installed. It could be just a hardware configuration issue that Realflow is not recognising. It could be anything. But I'm sure these problems get ironed out as we go along. Anyway, I've saved the scene now, so I don't have to keep, again, bouncing back and forth like I should have initially. So anyway, we're back to where we were. I've got this sphere as the object emitter, and I just need to drag my texture into this texture thing. Hopefully this won't crash. If it does, I don't know what I'm going to do. Oh, again, this sphere needs to be an editable object because it needs UVs. So I'm hoping that this won't crap the bed. Did we crank up the display? Yeah, we did. Okay, good. I'm hoping this won't crash. There we go. So it's actually doing what it's meant to do now. So if we actually have a look at the sphere, let's put the texture on the sphere. That might help. You can see that there's only stuff being emitted from where it's white on there. So yeah, that seems to be working as it should. Good. Okay, go back to the emitter, and what have we got next? We've got, what are we on? Object, are we? Yep, so sphere. Self-explanatory, this one. Let's get rid of our sphere. Let's hide this. So this one is, I mean, it's pretty obvious. It just emits from a sphere shape. Again, it's got a speed parameter, and it's got a random parameter, so you can randomize the particles just like the other emitters. It's got a fill sphere option, so it's just a full sphere at the beginning, bang, and then it explodes. If you don't want it to do that, you could probably alt with the internal pressure, something like that. So, yeah, not much to say about that one, really. The next one on the list is a spline. Now, this is interesting. So, let us create a spline. So if I go to the spline tool, and I'm just going to use the pen, so I'm just going to draw out a spline shape. It can be as random as you like. It doesn't have to be anything particular, so that'll do me. So that's my spline. Just for argument's sake, I'm going to center my pivot to the, instead of being world 0, I'm going to center it to the axis center, execute. So it's in the center of all the points of the spline, basically. So I'm just going to raise that up, and I'm going to go to the emitter, and where it's got this spline object field, I'm going to drag that in there. The emitter object's a little bit off. Let's just drag that down a bit, just so it's in the same position as the spline. In fact, we can hide this spline. It's largely irrelevant. And then I can move this emitter up so it's out of the way of, we can see what's going on. Okay, so this emitter then. We've got the spline object field, we've got the creation field, and the options you've got axis, tube, and edge. You've got the speeds, just like all the other emitters, and you've got this randomness, just like the other emitters. So let's have a look. So if I play it, it is going to be generating particles from this spline's edge, which is pretty cool. I think that is very, very cool. So let's just go through some of these options. So the creation is on its axis. If I go to tube, it basically gives the object a radius, so it craps out from sort of like a tube. Imagine a tube being swept along that shape. It generates from the surface of that, but you're probably wondering, why is it only travelling in one direction? And that's determined by these control points. So as you can see, this control point, it determines the radius, the radius of it, and it also determines the direction. You can see this arrow. So we'll get to that in a minute. The next one is edge. So it uses the first control point to crap particles out in the direction the spline is facing, if you like. Now, there is actually a way for you to be able to make these particles follow the spline's path round, so you can get some like twisted vortexy type water effects. But the best way to do that is actually through a daemon, one of the daemons, and I think it is called, let's have a look. Where is it now? It is called D-spline. So that's the best way to do that. So I won't be covering that in this tutorial. I'll be going over that in another tutorial about the daemons specifically. So let's just get through the emitters. And okay, so edge isn't particularly interested in this case, so I'm just going to turn it back to axis, and so we get this. So how can we use these control points to, control what's going on? Now, if I flip down this control thing, you can see which one of the control points is selected because it's white. And if I press next, or even better, previous, it will flick to this control point. Previous again, it will flick to this control point. Each control point has got some controls. So we've got an offset, so that will move this along. You can even add control points, so you've got more control points as you go along. So I'm just going to leave that at the beginning. Its radius you can control. in this case it doesn't matter so much, but if I was to change this from axis to tube, you can see that now this radius of control point 1 is a lot bigger than the radius for this one. And what it'll do is it'll blend between this huge shape and this not so huge shape. It'll try and blend between the two. So there you go, it's a lot more uniform now. Oh, it's because it's flipped back to axis. But yeah, so you can change that on the fly. So yeah, I can crank this up. Oh, that's the offset, sorry. There we go. So a lot bigger. So you can see how you can control different aspects of this spline. Let's go back to axis so you can see what's going on. Speed, you can have the emission coming out a lot faster for this control point. And as you can see, that it's very fast here, and as it gets down to this control point, which is of a slower speed, you can see the blend here. So it's great. Now this is the best part, rotation. So you can actually choose where it's emitting from. So up here is coming from this direction, and again it blends that direction as it gets round to this control point. It blends. So what if you want to change this one? Well, we just press next and it goes to this control point now. So now I could actually change the rotation of this one to be out here somewhere. So you can see that you've got a lot of control. I could even turn it back in on itself, I think. I think I might have to go all the way around. There you go. And then we'll get some interesting particle interactions there, probably. Maybe I need to turn it in on itself a little bit more. There we go. Some interesting collisions, just I don't think it had enough time. Let's give it a bit more time on the clock. Gotta pause it, 10 seconds. There we go. So yeah, you can see there's some particle shit going on there. Okay, so that's generally how you do it. And if I wanted to add, you can even delete them. So if I selected, say, this control point here, let's go back and select it and then hit delete, it'll get rid of that control point. I'm going to undo that. If I go to, say, the last control point and then say add, it'll, oh, actually, yeah, added one between these two control points. I could say add another one and it'll put one there. It looks like it's doing it uniformly. Oh, it's whatever one you've got selected. So if I've got this one selected and say add, it'll add one there. If I've got this control point selected and press add, it should add it here, I think. Yeah. Okay, so yeah, you can add more control points for finer control point control. So yeah, that's pretty much sums up that one. Again, let's go to the emitter, and the last two are pretty straightforward. We've got square for this one. So as you can imagine, that's fucking exciting, isn't it? It's almost identical to the circle one, but apart from being a circle, it's a square. Same options: volume, speed, vertical random, horizontal random, and side emission, so you can emit from the sides of a square. And I think it's pretty much the same for the last one, which is triangle, which is exactly the same thing, all the same options and side emission. So that kind of covers the emitters themselves. So they're sort of like the main crux of the location of point emission, and it's the fluid that actually holds the information about the particles themselves. So we'll be getting a lot more into the fluid and a lot more into these daemons and the mesher in upcoming tutorials. So I hope that was helpful for you guys, you know, as a sort of introduction and a first parter, really. Don't forget, check out digitalmeet.uk. You can vote on the next tutorials there, which is good. So I'll be putting a new poll up soon. Also, don't forget to support Digital Meet. If you've got a couple of shekels in your pocket that you can get rid of, go to the donation page on digitalmeet.uk. That helps keeps the lights on for me, and I can. It just means that I can make tutorials faster and spend more time doing it. And also, if you want to see something for your money, you can always support us by buying a Digital Meat t-shirt from the merch store. Just to let you guys know, I've updated the t-shirts now, so if you want to buy the updated Digital Meat logo t-shirt, that can be done now. All right guys, thanks for listening, and I'll see you next time. Bye.